Hello students, chapter 2 we are going to start, that is structure of atom. You have a basic idea of the atomic structure in class 9, but now we are going to discuss in details what is structure of atom. Let us start with the discovery of electron or the discharge tube experiment. In the year 1879, William Crookes studied the conduction of electricity through gases. He performed the experiment in a discharge tube, which is a cylindrical hard glass tube about 60 centimeter in length. It is sealed at both the ends and fitted with two metal electrodes, as you can see in that particular diagram. And you can see the cathode ray discharge tube as a diagram to you. Now cathode is negatively charged and anode is positively charged. You can see the electrical discharge to the gases could be observed only when at very low pressure and at high voltage. The pressure of different gases could be adjusted by evacuation. Now you see, when sufficiently high voltage is applied across the electrodes, current starts flowing through a stream of particles moving in the tube from the negative electrode, that is cathode, to the positive electrode, to the anode. And the effect of this experiment, you can see the bulb or the filament being glowing. The glowing filament gives you the induction of how the cathode ray experiment was successful and the electrons were passing. So this was called cathode ray or cathode ray particles. Let us see the properties. Number 1, they travel in straight line, cathode rays. Number 2, they start from cathode and move towards the anode. Number 3, these rays themselves are not visible, but their behavior can be observed with the help of certain kind of materials. The fluorescent, as I told you, the light, the glow of light, or phosphorescent, which glow when hit by them. Cathode rays consist of negatively charged particles. When electric field is applied on the cathode ray with the help of pair of metal plates, these are found to be deflected towards the positive plate, indicating the presence of negative charge. The characteristics of cathode ray do not depend upon the material of electrodes and the nature of the gas present in the cathode ray tube. So determination of charge to mass ratio was done for an electron, and J.J. Thomson for the first time experimentally determined the charge to mass ratio, which is also called E/m for electrons. For this, he subjected the beam of electrons released in the discharge tube as cathode rays to influence the electric and magnetic fields. These were acting perpendicular to one another as well as to the path followed by the electrons. Now according to Thomson, the amount of deviation of the particles from their path in presence of electrical and magnetic field depends on these factors. Number 1, greater the magnitude of the charge, greater is the interaction with the electric or magnetic field, and as a result greater is the deflection. Number 2, mass of the particle, lighter the particle, greater the deflection. Number 3, deflection of electrons from their original path increases with the increase in voltage across electrodes or strength of the magnetic field. By carrying out accurate measurements on the amount of deflections observed by the electrons on the electric field strength or magnetic field strength, Thomson was able to determine the value, that is E/m, E is 1.76 approximately, if you round off this figure, into 10 to the power 11 coulomb per kg, where me is the mass of electron and E is the magnitude of the charge. Charge of an electron, Millikan devised a method which was known as oil drop experiment to determine the charge, and was found out to be 1.6022 into 10 to the power minus 19. Now if I take out the mass, that is charge divided by charge to mass, the value comes out to be 9.1094 into 10 to the power minus 31 kg. With this, the discovery of protons was done in anode ray. In 1886, Goldstein modified the discharge tube by using a perforated cathode. On reducing the pressure, he observed a new type of luminous rays passing through the holes or the perforations of the cathode and moving in a direction opposite to the cathode rays. These rays were named as positive rays, or anode rays or canal rays. Anode rays are not emitted from the anode, but from the space between anode and cathode. Properties of the anode rays. The value of positive charge on the particles constituting anode rays depends upon the nature of the gas in the discharge tube. Number 2, charge to mass ratio of the particles is found to depend on the gas from which these originate. Number 3, some of the positively charged particles carry a multiple of fundamental unit of electrical charge, that is coulomb, and the behavior of these particles in the magnetic or electric field is opposite to that observed for electron or cathode rays. Next we have the proton. The smallest and the lightest positive ion was obtained from hydrogen was called proton. The mass was 1.67 into 10 to the power minus 27 kg, and the charge was approximately 1.602 into 10 to the power minus 19 coulomb. We have neutron. It was neutral particle discovered by Chadwick in the year 1932. By the bombardment of thin sheets of beryllium with fast moving alpha particles, it was observed that highly penetrating rays consist of neutral particles which were named neutrons. Then you have the next one, that is different particle size and ratio. So these protons, electrons, neutrons together it is called the subatomic particles. And after the discovery of protons, neutrons, electrons, the next part will be the different atomic models that we are going to study.